Gotta catch my breath, hold on. Actually, I went to this store a little past midnight. So it's a little past midnight here. And, yeah. And so I thought, like, restless person here, can't fall asleep. So what should I do? Well, there's other stuff I could do until work. But first, I wanted to take care of this business, yeah? Okay, this is, I promise, my last ode to MF, who, like, died a couple of weeks ago. Yeah, R.I.P. Okay, cool. So we're revisiting this thing, the MF integral. Right? Okay. No, it's derivative, my bad. Integral would have been more fun. Okay, so, like, this is I almost fell. Okay, this is actually why like, lost balance is more. Okay, so this is actually why, like, I'm talking through this, because, well, like, I think the derivatives require a little more, like, narration, a little bit more, like, hand holding in places. So, like, talking over the videos or what I'm writing is more useful when we're doing derivatives as opposed to integrals. Okay, so obviously we're going to take a different approach. Jesus Christ. Sorry guys. Oh, my balance. Okay, so this is the derivative we're interested in, right? We already saw how to solve this, but we're doing it differently this time. Okay. That's 1 plus 1 over x to the power x. Okay, 1 second. Uh-oh. Okay, and so this is how we could do it, right? Well, this is our different approach this time. And it is, well, see, like, 1 plus 1 over x to the x is equal to e to the power ln, and then 1 plus 1 over x to the x, right? The e and the ln are inverses, so we can go like this and return back to where we were, right? Okay. But of course, like, this rewriting is useful because then we can bring this x and write it right there, right? Now, good teaching, right? So like, good teaching from that I picked up from colleagues on, like, derivatives of e to the x is that, like, dx of e to anything, right? I might have showed you this before, and I know for most of you I don't need to break it down like this, but I will anyway. So the derivative of e to anything is, well, e to anything, you keep that, and then we multiply by chain rule by the derivative of anything, whatever anything may be, right? So then, following that, first of all, we see that the question is the same as asking for ddx of e to the power x ln 1 plus 1 over x. And so in this particular situation, anything is this, right? And it's a product between x and the natural log 1 plus 1 over x, right? So following that rule we wrote over there, we see that it's going to be e to anything. So that's e to the x ln 1 plus 1 over x, and then times the derivative of, so ddx of anything, so the derivative of anything being x times ln of 1 plus 1 over x. Right, fellas? Okay, cool. Now, notice that this here, right, if we retrace, is this here, and therefore it is that. So why don't we just call it back? So this is just what we had here. So that is 1 plus 1 over x to the power x. So So then that way we just concern ourselves with this here, and that's pretty straightforward. So then you see in our next step we could go 1 plus 1 over x to the x. And so for the derivative of this, as I said, it's a product, so we do product rule. And so I guess I'll break down that part quickly. F prime g plus f g prime, right? That's how it goes? Okay, so derivative of f being x, is 1. Of course, we need a parenthesis. And then times the natural log of 1 plus 1 over x. And then, so this is g. And then plus f, which is x. And then times the derivative of this. So the derivative of this here is 1 over 1 plus 1 over x. And then by chain rule, we multiply by the derivative of this here. Right? And that's negative 1 over x squared. In our first method, I showed you why the derivative of 1 plus 1 over x is this, like, more explicitly, so I'm not going to do that here. We cancel here, so we get x out of that. And we could stick this minus sign right here, and I think I'm missing a parenthesis right there. And all we require then is tidying up, and we is done. So it'd be like 1 plus 1 over x to the x. And what tidying up can we do? Well, here, as I showed you in the previous video, obviously the answers end up being very similar. It's like that, right? It's like x plus 1 over x, which is really like x over x plus 1, right? But we also have an x right here. So we'd have, well, we don't need to keep the 1. So we'd have ln of 1 plus 1 over x. And then it's minus, and then it'd be x over x plus 1, right? This times, and then 1 over x, right? So times 1 over x. And so that'd mean that we could go like, okay. Okay, so we could go like, boom, boom, right? So it tidies up a little bit more. So, okay, I'll write one more step, fine. You just don't want me to go to sleep, huh? Math, I'm talking to math. I'm not talking to you, I'm talking to math. Okay, so that'd be like ln of 1 plus 1 over x. And then, what happened here? Minus 1 over x plus 1, right? Okay. Do I need an extra parenthesis? No. Yeah? Okay, cool. Hope you enjoyed this. Yeah, keep watching. Take care.